Hey everyone, ready to dive into something really cool? We're looking at material science today.
Really cool and about to get even cooler.
Yeah, this AI tool we found in this Science Daily article is
Seriously groundbreaking stuff, yeah.
it's claiming to predict the optical properties of materials, get this, 1 million times faster
A million
than the
times.
ways we do it now. 1 million. I mean, come on.
It's a big deal for sure, like going from
Buggy.
yeah, exactly, to warp speed. But to really get why we need to look at how it's done now.
Okay, so right now it's a slow process.
Discovering new materials, especially for things like LEDs, those
Solar
things,
panels, yeah.
quantum devices, it takes forever.
So it's like what? Finding a tiny, tiny thing in a...
It's a needle in a haystack situation, but the haystack is huge.
Okay, got it. Huge haystack, tiny needle.
And the needle is like the perfect material.
So back up a sec. Remind me why these optical properties matter so much.
Right, so optical properties.
I know it's how light interacts,
Yeah.
but beyond that, I'm a little...
Fuzzy, sure. Think of it like this, a solar panel.
Right.
How well it absorbs sunlight, turns it into electricity, that's all about its optical properties.
So if we can predict those, then boom, better solar panels faster.
Exactly, and that's where this AI comes in, the one from Tohoku University and MIT. They're using this thing called a graph neural network.
Graph neural network.
Yeah.
A GNN.
Okay, that sounds pretty complex.
It is, but think of it
Like a map.
kind of. Instead of cities, it's atoms.
So the AI is learning how the atoms, like, talk to each other.
Exactly. And it doesn't even need tons of experiments to make its predictions.
No kid.
Just the material's crystal structure, which is basically like its blueprint.
Wait, so just from a blueprint, it can tell you how light will react to it.
That's the idea. And they're doing it with something called universal ensemble embedding, which I'll admit sounds very jargony.
It does, but break it down for me.
So instead of one AI model,
Yeah.
they're using a bunch of them, all working together, kind of like a team with different specialties.
So many AI minds working as one, and that gives them crazy accuracy, as good as the old methods, but way faster and cheaper. Remember that whole million times faster thing?
Yeah, it's kind of hard to forget that number.
That's what we're talking about here. It's huge.
So instead of testing one material at a time, they could do like 1 million.
It's a whole new world for research. Imagine finding the best materials for, well, almost anything so much quicker.
Okay, but this goes beyond just making a better LED bulb, right? What else could this be used for?
You're right, this is way bigger. The article focused on the optical stuff, but this approach, it could work for other properties too, like how strong something is, how flexible, even how well it conducts electricity.
It's like we're suddenly not limited by the materials themselves anymore.
That's a good way to put it. We might be on the edge of a completely new age of materials.
Wow, okay, I need to process all this.
Ah.
We're talking revolution in material science, and it's all thanks to AI. We'll be back after a quick break to explore just what this could mean for the future. Stay with us. Back again, diving deep into AI and materials, and I gotta say,
It's pretty wild stuff.
it really is. It's not just about doing things faster. It's like we can find materials we haven't even thought of yet, right?
That's the really exciting part, yeah. Instead of just hoping we stumble across something amazing.
Which is kind of how it's been done, hasn't it?
Pretty much, yeah. But now we could tell this AI we need this, this, and this. Find it.
Like a materials search engine, but way more powerful.
Exactly. Think about solar panels, for instance. What if we could find the perfect materials to make them crazy efficient?
And cheap to make too, right? That's the other hurdle.
Absolutely. It could revolutionize how we get energy, not just make things a little better.
Okay, so better solar, that's huge. But
And that's just one example. Imagine lighter building materials, stronger too.
you could build things differently.
Entirely. Buildings, maybe even, who knows, floating cities, that kind of thing.
Okay, now you're just getting me riled up. But seriously, this is powerful stuff. Are there downsides? There always are, right?
It's a valid concern. With any big change, some jobs might be lost.
That's what always comes up with AI, the robots taking over.
But think about it. What if it's more like they take over the boring stuff?
So scientists can actually, well, do science.
Exactly. Less number crunching, more big ideas, working with the AI.
Like a superpowered research assistant.
That's a good way to put it. And get this, the article mentioned they're already working on expanding this AI's abilities.
They weren't content with just revolutionizing one thing.
Apparently not. Right now it's optics, but next. Could be strength, flexibility, even conductivity.
So you're saying we could just design any material we want?
That's the goal. Need something super strong, but also super light. Tell the AI, let it do its thing.
It's like having a materials menu. I want this, this, and this. Boom, there it is.
It's not quite that simple, but you've got the right idea. It's about breaking down those limitations we're used to.
This is pretty mind-blowing. But how does this impact, like, the average person? They're hearing this and thinking, cool, but so what?
Fair point. Look around you, what's around us. Phones, cars, all of it uses these advanced materials.
And if we can make better materials?
Everything gets better, cheaper, lasts longer, better for the environment, all because the materials themselves are improved.
So it's like a ripple effect outwards.
Exactly. From something that seems super complex, the atoms and how they're structured, comes these huge changes to how we live.
It's a good reminder that even if we don't understand all the science-y bits,
It still affects us.
this whole AI thing, it's really got me thinking about how we make discoveries.
It's not just about speed, though that's a big part of it.
Right, it's like we can be way more intentional now,
Instead of just testing things randomly, hoping for a lucky break.
which, let's be honest, is what a lot of science has been, right?
Trial and error, for sure. But now it's like, we've got a roadmap.
And what's wild is that it all comes down to understanding the tiniest things, the atoms.
It's fundamental research, but with these incredibly practical applications.
Okay, so big picture time. We've talked materials, but you said this could work for other stuff too.
Absolutely.
Yeah.
Imagine this kind of AI in medicine.
Hold on, like designing new drugs, that kind of thing.
Even more targeted than that. Imagine medicine designed for your specific genes, your specific needs.
Okay, now that's just next level stuff. And you said climate science too. How does that work?
Right now, our climate models, they're good, but imagine if they were this accurate, this fast.
We could actually get ahead of the curve instead of always playing catch up.
Exactly. We could test out different solutions, see what works best, make smarter decisions.
It's like we're not just limited to reacting anymore.
It's about taking control, using these tools to shape a better future.
This has been an amazing conversation, really eye-opening. So as we wrap up, any final thoughts for our listeners?
We live in a wild time. Technology moving faster than ever. It can be overwhelming.
No kidding. But what we're talking about here, it's about using that tech for good, you know?
Exactly. And who knows what incredible discoveries are right around the corner.
So, to everyone listening, stay curious, keep asking questions, and let's see what the future holds. That's it for this deep dive. We'll catch you next time.